All right, guys, number 17 in section 2.8, it's kind of an interesting one. They give you a sixth degree polynomial function, and they're asking you to use the intermediate value theorem to show that this equation right here has at least 6 distinct solutions. Now, knowing what we know, everybody, about polynomial functions, we know that it can't have more than 6 solutions right there because a sixth degree polynomial can only have 6 at the most. But the intermediate value theorem doesn't guarantee there's only 6. It would guarantee that there's at least 6. Now, I don't think I've done this problem yet. I haven't looked at the solution just yet, but I think I have a feeling. I know how they made this one work out. I'm hoping we don't have to spend too much time on it. What we're going to do here, everybody, is we're going to go ahead and make ourselves a table of values here, which is going to be x and then f of x. And I suppose if I'm going to say f of x, I probably should have defined this function right here as that's what we're dealing with. F of x is equal to that whole thing. And what we need to do then, guys, is put a bare minimum of 7 values in this table right here and show that there are 6 sign changes in the value of the function there from positive to negative or vice versa. And I have no idea how hard they're going to make us look at this. Now, in every problem that we've done like this together, guys, I've said, okay, go ahead and use your calculator now and see what we can do to try to make this a little bit easier. So I'm going to do that same thing with you here. So we're going to go ahead and we are going to define this function here as f1 of x is equal to, all right, and here we go, and I'll go ahead and type in this function now. So it was x to the, where's that button? There it is, x to the 6th power, right, minus an 8x to the 4th, okay, minus 8x to the 4th, got it? And then a plus 10x squared minus 1. So plus 10x squared and a minus 1, and we hit done. Okay, and there it is. And now, guys, we're going to try to go to the table on our calculator and figure out what we're dealing with. Boy, and I kind of wish that for this one, I had an old TI-84 that I could set to automatically fill in the table for me, but we will make do. All right, what you guys are going to want to do is hit Control Document on your calculator to add a page, and we're going to want to add lists and spreadsheets, which for you guys is number 4. And I really have no way of knowing where I should start this table at, but I'm going to start it pretty far to the left here, guys. And in my first value in cell A1, well, there we go, I'm just going to type in a negative number, and I tell you what, I'm going to make it negative 10. I feel like that should be pretty far. And then let me show you guys, you could type these numbers in manually if you wanted, but I'm rather do this one with a formula. So I'm going to type in here a function here. I want cell A2 to equal the previous cell, which was A1, and then I want to add 1 to the value of that cell, which is negative 9. Okay, that wasn't bad. And the reason I did that rather than just manually typing in negative 9 is now I'm going to go and copy this cell. So for you guys, go to cell A2 and then remember, one finger at a time, hit Control and then C to copy it. All right, and then you guys are going to hit shift down a whole bunch of times. So shift down, shift down, shift down, shift down, and so on and so forth a whole bunch of times. And then we're going to hit paste. And yes, it's okay to overwrite your values. Hey, and there you go. So now I've got a column that goes from, let's see, negative 10 to positive 6, and I could fill that in if I needed to. Okay, if it needs to go further, but maybe that's enough right now. The next thing we're going to do is we're going to use our arrow keys to go to this cell right here, guys, which is above cell B1. And this is a feature of the spreadsheet on your Inspire that Google Sheets and Microsoft Excel don't have. You can type a formula in up here, and that's what I want to do right now, guys. So we're going to put an equation there, and we're going to write equals, and let's see, we said, we named our original function f1 of x. So I'm going to type in equals f1, and I think that's good enough right there, guys. If I just hit enter, nope, obviously that is not good enough. All right, let's try that again, f1, and then I think we need to put a set of brackets here. And if I remember where to find that, let's see, would brackets be hiding here on a keyboard? No. Uh-oh, haven't done this on the app yet, guys. It's probably, there it is, kind of a second function of the parentheses. And I think if I put an A in there, that might do what I needed to do right there. Oh, nope, that's a problem. Okay, Mr. Fontana should have tried this before he made a video of it. All right, so let's try this again. Now I'm thinking if I put the A inside of those brackets and get rid of that A, maybe that's going to work. Let's try that. Nope, that wasn't it either. Okay, F1, maybe I don't need... F1, maybe we needed parentheses after that of that one there. Okay, let's try it that way. Overwrite, invalid expression. Okay, well, we're going to try this a different way then, guys. What I'm going to do is just within cell B1. Let me go ahead and, actually, I'm going to clear all of this out here. I don't think I want any of that junk there anymore. Okay, and within cell B1, I will clear that out, and I will just manually type in this equals, and we are going to do the function we talked about, which was F1 of, and now I'll just have it directly reference cell A1 to its left. Okay, wow, and I got a big number right there. That's okay, that doesn't surprise me. Now, I'm going to go back up here to cell A1, and I'm going to copy that, and then for you guys, so that was Control-C to copy, then you're going to do Shift down a whole bunch of times here again, and then you guys are going to do Control-V for paste, and it's going to ask you if you want to overwrite that. Okay. And there we go. And this is about what I was hoping to see in my table, at least so far here. So I started off, let's take a look in this B column, with some ridiculously high Y values right here. And okay, so this function is way, way, way positive here. And then it's getting less positive, less positive, less positive. Now we're coming down into more normal numbers. So I definitely started this table further to the left with -10 for X than I needed to, but that's okay. I'm interested in sign changes, everybody, and I'm starting to see quite a few of them. I don't know that I've found enough of them yet, though, but let's take a look. There is a sign change right here, you guys, between 170 and -25. There's a spot there where this thing has to equal 0. So there's at least one solution to this equation between -3 and -2. That's one. There's another one right here between -25 and 2. That's 2. There's another one right here. That's 3. There's another sign change here. That's 4. There's another sign change right here. That's 5. And there's another sign change right there. That's 6. And that's the number that I was looking for. So if I were you guys, what I would do is I would probably copy these numbers right here into my table right there. All right. And then what I would start to write down here is the fact that there's got to be a 0 somewhere in between the 170 and the -25. So that tells us there's one solution between -3 and -2. And basically, yeah, this is what I was hoping would happen. Looks like we've got, what, 7 Y values in a row where the values alternate signs. Positive to negative to positive to negative to positive to negative to positive. Okay, so that was 6 consecutive sign changes right there, which means that there are 6 solutions to this equation. So there's not actually much that I'm going to write down right here, but that's what I would do if I were you guys. I'd put those 7 values in the table right there and show that we have 6 sign changes in your Y values right here. And so therefore, we must have a minimum of 6 solutions where this equation has to equal 0, because that's what has to follow when the Y value of a continuous function changes sign.